Welcome to another video from the Concord Pro review. This video will show you how the collaboration between a PCB designer and a mechanical engineer works in practice. As an example, I will use an earlier created board developed in Altium Designer that has not been registered in Concord Pro before. We'll go through the process that the majority of existing Altium Designer users will encounter for existing projects. I will demonstrate how it can be registered in Concord Pro and later opened within the SOLIDWORKS MCAD tool. We'll use the default example project mini PC included with Altium Designer installation. I'll focus on the Wi-Fi board since it's not too big and we can use it to demonstrate some of the benefits you'll get. Here's how it looks in Altium Designer. In order to make the board available on the SOLIDWORKS site in the future, you must open the whole project and register it in Concord Pro. This can only be done to the whole design and not to individual board files. In the Projects panel, right mouse click on the project file and use the command Make Project Available on Server. You will invoke the dialog where you can adjust the name and description of the project. Remember that meaningful project descriptions allow you to search quickly through the projects in the future. I will leave the default information and click OK. For the scope of the current demo, I recommend not changing any other options. Once the project is registered, we can move to the MCAD Co-Designer panel that enables our collaboration. I can open it in the usual way via the panels list. It is available by default in the latest versions of Altium Designer starting from 19.0. In rare cases when it's not available, you can install it via extensions and updates. In the list of the installed extensions, we can quickly check if it is installed. If not, we can go to the Purchase tab and install it from there. Once we have made sure the panel is installed, we need to share the board information with the MCAD designer. For that, I simply press the button, Push and Share, while having the board as the active document. Since this is a demo and I'm using my own account from both sides, I'll just push the data without sharing. We'll enter some description of the data snapshot we sent and click Post. Altium Designer starts preparing the data. It gets the copper geometry, processes the 3D bodies, and other information that is needed on the MCAD side. With time, once all reusable data gets cached, the process becomes much faster. In order to demonstrate the MCAD side, I'll switch to the MCAD tool. For the purpose of this demo, I'll use SOLIDWORKS, but it is the same in PTC Creo and Autodesk Inventor. The MCAD tool also requires a panel to be installed. For that, I'll go to the Download section of Altium.com and select the plugin for my tool. After the plugin is downloaded, I'll launch the install and use all the default settings. Note that you need to install the plugin first and only then launch SOLIDWORKS. I'll start SOLIDWORKS and go into Preferences, Add-ins. In the list of the available add-ins, I see a new one, called Altium Co-Designer. We enable it and mark it as available after the application startup. After that, the Co-Designer panel becomes available within SOLIDWORKS UI. From that panel, I can either initiate a new project or open an existing one that the ECAD engineer has shared with me. In this demo, we will open the existing project we have registered from the previous step within Altium Designer. First, I'll be asked to connect to the server. Since Altium Concord Pro is an on-premises product, we will choose the custom server option, and we will put the address of the Concord server. Since we installed the server in the same machine we're using for this demo, we will just type localhost :9780. We'll use default user and password, admin, admin. You may want to remember these credentials for the future. After that, we are asked to select which project we want to open. In the list, you can see all the projects available to my user. Once I click Open, the system asks me to select a local assembly file name and location for the board. We will select a dedicated folder for this project, where all the data from the assembly will be stored, including component models. After that, the native SOLIDWORKS assembly is being created using the data we pushed earlier. Please note that this is not an intermediate format, it's the full assembly with the native file structure. After that is done, I can continue working with it, as usual, using all native SOLIDWORKS tools and approaches. I'll show several scenarios of the bidirectional exchange and workflows in the next video.